Welcome at part 2 of this tutorial. In this part we're going to create the detonator top. All dimensions are shown on screen. We see that the model is standing straight up. We will use a revolve to create the outer shape. So we will start sketching on the front plane. Let's go. New part. Front plane. First we create the center line, which will be used to revolve. The object is 42 millimeters in height, so just make sure your line is higher than that. It makes it easier to do the modeling. We have the outer shape. When you construct the shape, make sure that you do not make any unwanted relations. So don't make that mistake, because otherwise you will find it difficult to dimension it later on. Well, that's okay. I can correct that one. That should be vertical. There. Then we go all the way down. Okay. This line and this line should be equilinear. Important. So that's the basic shape. Let's put in some dimensions. Let's start with the circles. Inside dimension 8 millimeters. Put a diameter sign in front of it. The outside is 14. Outside of the flange. 16 millimeters. And now we see that the model is losing its shape because of this. This is not a problem. We can just drag that line outside again, like this. Next diameter is this line, 3.5. And the last one is the upper body, 10 millimeters. Okay, let's continue. That height is 1. Sometimes it's important the sequence you do the dimensioning in. So I normally start with the small ones, so I'm certain that they stay in shape. Is that correct? No, it's not correct. 7.5. What else? This height is 2 millimeters. Getting out of shape. Let's forget about it. Then we first make this relationship. 1.5. Then change this to 2. Okay, and what do we know? Bottom to top here. It's 18. We know the total height. It's 42. And from underside of this flange to the top, 32. So as you can see, we have fully defined the shape. There's still two things missing, and that's we have to chamfer 1.5 millimeters between those two lines and between those two lines. Okay. Now you see it's underdefined again. It's because we cut off this part of the line over here. So to get it back fully defined, we have to select this line and this point and make it fixed. And now it says it's overdefined. Why is that? This line and this point. Make it coincident. Now it's fully defined. Okay. So now we have a fully defined shape. So that now we can revolve. Already selected midline, and there we have the basic shape. Okay, what's next? Let's look at the drawing. So now we will continue to make this cutout here on top. Here are the dimensions. It's at the front of the drawing, so we select the front plane to sketch on. Make a center line. You can use a second center line horizontally. Now we select the center right angle, put it there in the middle, intersect like this. Okay, it was 7 millimeters. 7. That one was 5. And the distance between the bottom and the top of the flange, that distance was 23. Okay. Now we put in the fillets. They were 1.5, no, 1 millimeter. Pieces, select them. Okay. We see it's fully defined now. We can exit. So now we do an extruded cut. We have to go to the front. So we have to flip sides. Now we have to flip direction. We can just leave it as this. We can leave it blind. We can say go through all up to next. It all comes out with the same result for this shape. So let's see upper cut. So what's next? Let me see. That's this small hole that goes through. So we have to use the right plane to construct it. Right plane, sketch on it. Again, we make 2 center lines. That's one. I'll do it differently. Make this one shorter. It's easier. Like this. Put a circle on it. Like that. Dimension 2 millimeters. The height 8. From the center line of the circle to the center line of the object was 2.5. Okay, fully defined. Let's exit. And now we can do extrude cut again. We choose through all both. Check it, and there we have the hole. So 2 more things left. No, 3 more things left. We also have the chamfer 1 millimeter. That's what we're going to do first. And then we're going to construct this thread. The thread is a little bit more complex than the one before. We did in part 1. So I'll give some more explanation on it. Let's put in the chamfer. For this we choose chamfer. Where is my... No, it's not fillet, it's chamfer. The chamfer was 1 millimeter. So already has selected one. It's the bottom outside. Okay, chamfer. So the first thread is the outside thread. In this drawing, you can see the measurements for the thread. So this was already predetermined. And we also know that the offset is 2 millimeters. That means the offset of the start of the thread is 2 millimeters outside of the body. Okay, let's do that. So that means we have to create a plane. The plane is 2 millimeter offset, like this. Start sketch on this plane and we convert the outside of the body. Okay. Then we go to features, curves, and select the helix spiral to create it. We have a variable pitch. As you can see here, variable, 2 things. We have a height and we have the pitch. So variable, we have height and pitch. And we have to reverse the direction. So we know height, the pitch was 2. Diameter was 14, automatically selected that. Then we go for a height of 10. The pitch of 2. Diameter is 14. So it automatically calculated the revolutions. Then we have a height of 11. With the same pitch, but now we select a diameter of 16. So we can see that when the thread is formed, it will slowly go out. This will also be the case normally when the thread is created with a machine, because the machine cannot go all the way up to the edge. So you have to stop earlier than that. That's why it's ending there. We did, let me see, we did start at 0 degrees. That means we have to start on the right plane. Sketch on the right plane. To create the thread, the cutout. It starts there, so that means that the small side should be on the inside. Here the center line. Then we will drag the cursor around it to select all of them and check mirror entities. put the dimensions in. This was 0.2. This is the same thread as the body has that we created in part 1. 1.8. And this is 1. So this is what the thread looks like. This is also what we used in part 1. So now we have to put this middle point, that line together. Point and that line by holding the control key and select pierce. Okay, now it's on the spiral. So now I can exit the sketch and make the cut sweep. What you will see now, when I select this, it shows the correct preview of what's going to happen. You see the thread rotating and in the end go outside. Now I press enter. Whoa, something wrong. What happened? This is because SolidWorks has problems when you use a spiral that runs outwards when you use the cut function. But there's a simple solution to that. We go back to the sketch, edit sketch, and we will just on the outside we make a extension and we trim the original part. So now it is extended to the outside. The length is not important. So if we now leave this, do another try, select the sketch, select the spiral, and now you can see it has done the job correctly. Let's hide the spiral, hide the plane. So now you can see the thread is constructed the way it should be. So the last thread we're going to make is on the inside. On the diameter of the 8 millimeters. Okay. This one will work on the top plane, sketch. We select convert entities and select the inside diameter. Go to features, curves, helix, reverse the direction. So this also has a height and pitch with a variable pitch. Start at 0. The pitch height was 0.6. The second one is at 72 millimeters, 0.6. So it's already calculated the revolutions, and we leave the diameter at 8. And then we go to the third, is 7.8, 0.6. You see it's another completed revolution, but that we change this to 7 millimeters. So that means in the end, the thread will move to the inside and you get the opposite of what we have here on the outside. We started again at 0 degrees. So we start on the right plane with the sketch. The cutout will go to the inside, so we are on the or to the outside. So that means on the inside we have the bigger height. Same shape, center line, select all mirror entities. Smart dimension. We know this height was 0.55 and this height 0.05, and the depth of the thread is 0.5. Okay, so that's it. So now we have to bring we see what it. Okay, let's just put it in like this, and then we can see what is wrong with it, because I thought the thread started on this side. But anyway, we know that we have to choose this side to pierce it. But if we look, we see it is the wrong way around. We can simply solve this by rotating the entities around that circle 180 like this. Okay. Exit the sketch. Now we do the revolve cut. When we select it now, we also have changed the last revolution. And for some reasons, it does not have the same problem as the one before. So when I create a thread on the outside, that slowly leaves its boundaries, we don't have the problem when we do this with a thread on the inside. Strange feature of SolidWorks. Okay, let's check if we section. Okay, so now we can see what it looks like. So we have the fully defined detonator top. The only thing is left is the material. It was on the drawing steel, and it was matte steel. Okay, so now we can save the part and move on to part number 3. Thank you for watching. I hope you liked. If you have any questions, any comments, please let me know. Thank you.